And so to begin with, we have looked already previously at this table of some examples of neutralization reactions where an acid combines with a base to produce a salt and water. And so notice the blue highlights are the portion of the acid that combines with the portion of the base to form the salt. Now remember some key things here. You always put the cation first and then the anion. Another way of saying that is the positive charge is written first, so that is your H of the HCN, and then your cyanide is the negative portion of that molecule, and you write that second. So that's why your sodium and then your cyanide is written here. To write CnNA would be incorrect. So you've got an acid plus a base yields a salt plus water, where if you look, the proton plus the hydroxide form HOH, which is the same thing as H2O. And so in each of these examples, you have an acid plus a base yields a salt plus water. It's pretty easy to see, but sometimes it takes a little bit of effort to practice those and predict what salts are formed by the interaction of an acid with a base. So we're going to practice. And so good ways to practice is just to take a list of acids and a list of bases and just combine them. So I'm just going to choose one random acid and combine it with a random base, and we're going to practice predicting what the products are going to be if you form or if you neutralize an acid with a base. So our first one is going to be when hydrochloric acid is neutralized with lithium hydroxide. So remember hydrochloric, so you've got your chlorine, ic is the naming, and then acid after the end. And so whenever we're doing this, also practice your naming. So in this case, you have hydrochloric acid reacting with lithium hydroxide. The first thing I do is I try and break apart the ions that are present here into their respective portions. So in order to do this, HCl is hydrogen with chlorine. And so you can look at your periodic table and remind yourself that hydrogen is a positive 1, chlorine is a negative 1. And then do the same thing for lithium hydroxide, remembering that hydroxide is OH negative. Lithium is +1. Another way you can do this I like to talk about is uncrossing the charges, meaning hydrogen has a little 1 subscript and chlorine is a 1. You just can't see it. It's an understood 1. So if you uncross the charges, you just make the subscript of the chlorine become the charge of the hydrogen, the subscript of the hydrogen becomes the charge of the chlorine, and so on and so forth. So now you have broken the different compounds apart into their respective ions. This is what happens when you toss lithium hydroxide and hydrochloric acid into solution. They immediately break apart. They're both strong acids, which means they completely dissociate. So now instead of having lithium hydroxide as a complete structure, it's broken into its respective components. Now they can find each other. And what's going to find each other is protons, are the hydrogen ions, are they really going to combine with the lithiums? I hope you thought no, because they're both positive. So two positive charged small entities, when they come in contact, they're going to repel. Same thing for your chlorine and your hydroxide. They're going to repel each other. So what's going to happen is the two negatives, negative is going to find a positive and the positive is going to find the negative. Okay? If hydrogen combines with chlorine, it's just going to re-break apart because it's a strong acid. So they're not, if they find each other, who cares? They're going to knock each other into each other and then bounce right back apart. So instead, we create what I call like a double rainbow. The idea that the chlorine is going to find the lithium from the other species, so the cation finds the anion from the other species, and then the cation and the anion from the opposite species form. So it kind of looks like a little rainbow, so like rainbow, rainbow, and so basically you're going to break them apart and then recombine them. And so this is typically how you would do a neutralization reaction. Figure out what components are in there and then recombine them with the other entity in the solution. So now we've got lithium and chlorine. We've got hydrogen and hydroxide. Therefore we have lithium chloride and water. So now we can just write the balanced chemical equation where hydrochloric acid plus lithium hydroxide yields lithium chloride plus water. Another way of saying this is an acid plus a base yields a salt plus water, where my salt is lithium chloride. Let's try another one. This time we have hydrobromic acid being neutralized with barium hydroxide. So the first step is to break the ions into their different charges. So give that a try on your piece of paper. Pause the video if you need to. Hopefully you came up with hydrogen and bromine, barium and hydroxide. Barium has a 2+, so the subscript here on the outside of the hydroxide forms the charge for the barium. The barium has a 1, which is your charge for hydroxide. All right, now form your double rainbow. Double rainbow, there's one. There's the other. The H plus the OH is the easy one, that's water. And now your barium combines with your bromine. Remember, your positive is always written first. That's by convention. Cation goes first, anion goes second. Positive, then negative. You got to cross the charges, so you trade them. So barium's a 2, so that means it gets a subscript of a 2. Bromine is a -1, so barium gets a subscript of a 1. So this is your neutralization reaction. Hydrobromic acid plus barium hydroxide yields barium bromide plus water. If you'll notice in this equation, your bariums are balanced, your bromines are not. Neither are your hydrogens or your oxygens. And so you have to fix that by balancing the chemical equation. So now we have 2 hydrobromic acids plus barium hydroxide yields barium bromide plus 2 waters. And so if you notice, now my bromines are balanced. Now my hydrogens and oxygens are all balanced. Let's do one last reaction. In this case, sulfuric acid is reacting with sodium hydroxide. First, pause the video and predict what are the ions that are going to be formed from sulfuric acid and from sodium hydroxide. Hopefully you saw hydrogen ions plus sulfates, sodiums, and hydroxides. Notice you could have written a 2 in front of the hydrogen because there are going to be 2 of them from every one sulfuric acid. So now you have predicted the ions that are formed. Use your double rainbow to recombine them, allow sodium to find sulfate, and allow hydrogen to find hydroxide. That predicts sodium sulfate and water, where sodium sulfate is your salt. So now when you write your balanced chemical equation, you have sulfuric acid plus sodium hydroxide yields sodium sulfate plus water. And then you have to balance it because look, the most obvious thing to me is your sodiums. Your sodiums are not balanced. A nice convenient thing to think about is for neutralization reactions, if your salt is not balanced, you're probably also going to have to change the coefficient in front of the water. And that is what we did here. You place a 2 in front of sodium hydroxide and a 2 in front of water, and it is now balanced.